In Exhibit 1, what is wrong with the scientist's claim is that the math he has done is not correct. The heart should not beat 600 million times per year, but rather it would be 60 million times per year if the math was correct. This example of slippery evidence is called a misplaced decimal point. Slippery evidence can interfere with human inference because usually when given information like the scientists gave us, we tend to believe that and we won't actually do the math for ourselves. So when we are given wrong information, we will make wrong inferences about that information. In a follow-up study, the scientists claimed that people who eat fast food will soon develop heart disease. But the scientists cannot claim this because there are a lot of other variables, which could be called lurking variables, that are not taken into account for. One variable could be is if the people in the study exercised or not. If someone who was eating fast food but did not exercise at all, that would probably lead them to get heart disease. But if someone ate fast food but also exercised, they might not get heart disease, but they're still eating fast food. Also, if, on the other hand, if someone was not eating fast food but did not exercise at all, that could also lead them to get heart disease. Another reason why the scientists can't claim this is because the probability that someone will get heart disease based on their family history is not taken into account for. Some people are just a lot more likely to have heart disease than others, and this needs to be taken into account for in the study, and just because they eat fast food or not is not going to be the only reason they get heart disease. These next answers will come from questions in Exhibit 2. Correlation is the measure of straight line association, and causation is when one thing causes another thing to happen. You can have a correlation but no causation between two variables. The correlation coefficient is a common numerical measure of a straight line association, and it is denoted with the numericals between -1 and 1 and is represented by the letter R. You can have a positive association when your correlation coefficient is equal to 1 and your graph will look like this. When it is up and to the right, you can have a negative association when R is equal to -1 and your graph will look like this and it will be down and to the right. Or you can have no association at all when your graph is scattered throughout the entire graph and your correlation coefficient will equal 0. Variables that are associated but have no causal relationship at all are that the street lights come on when the sun goes down, and two variables that are associated and do have a causal relationship is the amount of alcohol you drink and your BAC level. We are studying this as part of our slippery evidence because even though two variables might be associated, they are not causing each other. Even though we might think they are, what's actually causing the response in the experiment is what we would call a lurking variable that is not being accounted for in the study, but is really the reason for why some results are the way they are. But we have no way of knowing this, and therefore our results become slippery evidence.